Hello everyone and welcome back. This video is very similar to the polyester video that I have showing the formation of polyethylene terephthalate. This is a polyamide video for this reaction here. It's the formation of 6,6 nylon from adipic acid and 1,6-diaminohexane. This one uses the line system, the geometric formulas, because the two monomers are quite large. As you can see, there's 6 carbons in between each functional group. So we use the line system just because it's a little bit easier, makes it a little bit faster when drawing out the structures. You can, of course, use structure formula if you like, if you find that a bit easier. There's certainly nothing wrong with that. All right, this is very similar to the polyester, the polyethylene terephthalate reaction. It's a diacid and then a diamine instead of a dialcohol. But the process of it is quite similar. So if you've watched the polyester video, you might be looking at this one and say, you know, yeah, I kind of get this, and it's very similar to the other one I've watched, the other condensation polymer. And if you know one, you know, you can pretty much do both of them. They're very, very similar. So I'm going to start with the diacid. So this is a 6-carbon chain. 1, 2, 3, 4, 5, 6. And then a double bond O, OH on either end. So this is my diacid. This is going to react with the diamine, which has also 6 carbons in a row, and a nitrogen, 2 hydrogen on either end. And sometimes I may draw the hydrogen on the ends here, and other times I may just leave it as a line. So keep in mind that there are 2 hydrogens attached to that nitrogen. A little different than the polyester. This reaction only requires heat to get started, generally above 100 degrees. Okay, so no strong acid for this one, so that's a little bit different. It's condensation, of course, so this reaction is going to try to produce water if it can, and it certainly can at more than 100 degrees here. The OH is going to come off the acid, and one of the hydrogens will come from the nitrogen, from the amine side, and this will make water. And then the 2 pieces are going to join together where each of them has lost something. So the carbon that is right here, you can see darker circle, this carbon is missing a bond, the nitrogen is missing a bond, and these 2 are going to join together, creating our polymer chain. Very similar to the polyester, it grows from both directions, but I'm only going to show the right-hand side just in the interest of space and so that the molecule doesn't get like insanely huge here, kind of on the paper. So I'm going to start by drawing the acid minus that OH, because that OH has gone into water. So remaining of my acid is going to look like this. That carbon that's right here now has a nitrogen bonded to it. So there's my nitrogen. On that nitrogen, there's 1 hydrogen left. 1 was made into water. The other one's remaining. And then we have a 6-carbon chain. So there's 1, 2, 3, 4, 5, 6, and another amino group. Or amine group, I'm sorry, on the end. There we go. There's our first functional group, the amide, right here. Carbon double bonded to an O, to an oxygen, and single bonded to a nitrogen. This is, of course, a polyamide, so we're going to make many, many amides together. All right, keeping in mind that it's going from both sides, but I'm only working on the right-hand side, so I'm looking at the right hand of the molecule. It's an amine, an NH2 on the right side. This is also an alternating copolymer. So this is going to add the opposite functional group. Amines and amines generally don't react. Acids and acids generally don't react. Amines and acids, however, will react. So this is going to add the diacid. I'm going to do this one a little different. I'm going to kind of do this in a bit of an S sort of shape here. I'm going to draw my diacid. 1, 2, 3, 4, 5, 6. There we go. Just make sure I have enough carbon in between. I don't want to leave one out. Again, it's going to try to, oh sorry, that's an OH. It's going to try to make water. So the OH comes off of the acid and the hydrogen from the amine together. These will produce water as one product, so H2O, plus the two pieces are now going to join together. So I'm going to start by drawing that first compound again, minus the hydrogen that's on the end there, minus that hydrogen off of the amine. And you can see how with the 6 carbon chain, it does get, you know, quite lengthy, quite fast. So if you were showing this from both directions, obviously, you know, it's going to be a mess after 1 or 2 steps. You got a lot of molecules going on here. So that nitrogen now, it lost its bond, okay, it lost its hydrogen, and the carbon right here lost its OH. The two of them are going to partner together, they're going to join, and we're going to create a bond here to this carbon. Let's just show it kind of like this. There's my carbon, there's a double bond oxygen on it, and then we've got 5 more. So that's 1, 2, 3, 4, 5, 6. 6 in a row, again with a double oxygen and an OH. Okay, so I've got 2 amide groups in here now. Oh, sorry, and then this nitrogen has a hydrogen on it. My bad. Here's my 2 amides right there, CON, and then another one right there, CON. Okay, one last step. So this molecule now, again, I'm only working on the right side of the molecule. This is an OH now on the right side of the molecule. This is going to add, of course, the alternating monomer. So acids and acids don't react. Acids and amines, however, will react. So 2, 3, 4, 5, 6. Here's my amine. Hydrogen, hydrogen. Hydrogen, hydrogen. Okay, so one of those hydrogens are going to form water with the OH. So I'm going to kind of do like this. So it's going to form water. Let's take this one here. And the OH from the previous molecule, that's making water, and now the 2 pieces are going to join together. So if I'm going to show this, it's going to be a big arrow here this time. So this nitrogen is bonding to this carbon right there. Okay, I'm going to redraw that whole molecule again, or at least try to, so that I don't mess it up. 2, 3, 4, 5, 6, double O, nitrogen, hydrogen. 1, 2, 3, 4, 5, 6, nitrogen, hydrogen, carbon, double O, 2, 3, 4, 5, 6, double oxygen. The OH is gone, and wait now, I gotta go back, write my acid on that side. Okay, the OH is gone, that's this one right here. That's gone into water, and then the nitrogen is going to attach right here. It has 1 hydrogen left on it, and then there are 6 carbons, so 1, 2, 3, 4, 5, 6 with a nitrogen and now 2 hydrogen on the end. So I've made my polyamide, 3 amide groups, and I'll just put a little bracket around them so you can see each one. There they are. There. Right? I've actually made, in that 3-step process, it's actually 6 because the other side of the molecule is also growing a polymer chain as well. You can imagine how long it would be if we were showing both sides and 3 additions for both sides. I mean, it's quite big, especially with this 6,6 nylon process. But you can also see hopefully how very similar this is to the polyester. So the reaction to make an ester or to make an amide are very, very similar. They're both producing water at every stage. Water comes off as a gas because it's greater than 100 degrees initially to start this. But the actual process and how they sort of fit together, the pieces fit together, is very similar in both the polyester and the polyamide. I'd have a look at both of those videos and try these questions yourself. Try, working through that process on your own. Do it a couple days, take a break, come back a day or two, try it again. They're very repetitive, which is great. Makes it a little bit easier to sort of remember and work with that process. But if you don't practice it, it's going to be really hard to remember. So give it a try yourself. And of course, let me know if you have any questions, and hopefully you'll find this video helpful. All right, take care everyone. See you soon.